Welcome to another edition of Access Higher Ed. I'm your host, Christina Barrett, Director of Marketing and Student Recruitment at Berkshire Community College. Our show focuses on what's happening in higher education here in the Berkshires and beyond. But today we have some special guests that are not just from Berkshire Community College and from higher ed, but actually our friends from high schools, specifically Taconic High School. So I'm joined by actually 5 of them. The first 3 you will meet now, and the 2 you will meet later in the second half of the show. So first I want to introduce Bob Mossman, and Bob is an adjunct professor of technology engineering at Berkshire Community College and also works at Taconic High School as well. So Bob, if you want to just talk about your experience at Taconic.
Yeah, well, I got involved, I retired from General Dynamics. I've been an engineer, an electrical engineer for 50 years, and really wanted to give back as well as, you know, stay engaged. So I got involved with Berkshire Community College, and then through this program, this Bridge to College program, we got involved with the students at Taconic. And it's, you know, the last couple of years we've been trying to get our footing and find out what works, but the overall idea that we have is to try to get students engaged and understand what engineering is about, basically.
Great, thank you so much. And you're joined by 2 students that you work pretty closely with.
Yes.
We have Libby and Ryan. Libby, if we want to start and just tell us a little bit about yourself.
Hi, I'm Libby Gillette. I go to Taconic. Me, as well as the other students here, are part of the Science and Engineering Academy at Taconic. So we've just kind of been able to take this course through the Bridge to College program. And it's a lot of fun.
Great, great. And you're a junior?
Yeah, I'm a junior.
Great. Thank you, Libby. Ryan.
My name is Ryan Sayre, and I'm in my junior at Taconic High School. I'm enjoying all my science classes, especially this one with Mr. Mossman here. I've been working really hard on this project.
Great. Great. So we have some things that we're going to show viewers a little bit later that I know that you all have been working pretty hard on over the last few months. But that's in preparation for something that's happening tonight. And it's, as far as I understand, an annual event. Started last year. This is the 2nd year.
Right.
So if you want to talk about the program, and then maybe the students can share how they prepared for this program tonight.
Well, the program, it's actually a competition that's been sponsored by General Dynamics. And the whole idea behind the competition is to try to get the young people involved in engineering, and you know, they're trying to get the engineering field back to what it was in the past.
Sure.
You know, for the last 20 years or so, the engineering field is declined in popularity.
Mm-hmm.
Okay, and we're trying to get the kids to understand what engineering is about, for one thing, because I remember very well when I was in high school that I really didn't understand what an engineer did.
Mm-hmm.
Okay,
sure.
And so what we're trying to do is you know, have the kids understand what engineering is about. And the best way to do it, this is a great idea that General Dynamics has, because they sponsor a competition. They come across with some requirements. In this particular case this year, we had to shoot a what they call a buckyball. And you've got to lob it between 30 and 50 feet. You've got to be able to control the azimuth and the elevation, and you've got to be able to fire the device, whatever it is, automatically or remotely.
Right.
Okay. So, you know, it's a good engineering project, and it gives the kids a good feel for what that process is and how to go about it.
Right.
So we're kind of excited about it. We've gone as far as we can, and we're going with what we got. But it's been a good experience, so we're looking forward to that tonight.
Great, great. Now, Bob had mentioned that there's some sort of remote that is involved in lobbing these balls 30 feet. And so I understand that there's some application development that was used to help this happen. So can you speak to your role in developing this app? What does it even mean to develop an app? I think most people have them on their smartphones, but in terms of developing them, that sounds like a pretty unique skill.
We were able to develop an app using the MIT App Inventor that's provided online it's a free program. and you're able to insert coding and change your interface depending on what you want it to do. And we had ours run in Arduino, which is a small computer board, and it's able to change the electric current to be able to activate the switch that we use on the cannon.
Great, great. Brian, did you have involvement with this app as well?
I've had a little experience with it, but it's mainly been Libby and the other student, Jason, who's been working on the app.
Great. And we will meet Jason in a moment.
Yeah, I just want to interject here. The nice thing about this project was, you know, we've got 5 students involved, and the division of labor, the way things fell out, you know, the kids kind of, you know, Libby had some experience with programming,
Sure.
so she naturally went for the programming aspect of it. You know, Ryan's good in physics, and this ends up being a classic projectile motion physics problem. And you know, Jason, for example, they had to have a trifold that has some graphics on it.
Sure.
And he's very interested in that, so he fell into that.
Okay.
And Brian likes anything mechanical that he can work with his hands. So it just naturally fell out nicely, and everybody went off and you know, as Libby mentioned, this MIT App Inventor that's free online is a great way to teach kids about these electronic devices and how they work.
Great, great. And we will, once again, we'll meet Jason and Brian in a few minutes. But Ryan, you shared before we started the show that because you're physics background, or that you're taking physics courses, that you have a unique role with this group and kind of what's happening. Can you share a little bit about that?
Yeah, so right now I'm in AP Physics, and I'm the only one in the group who's taking physics or has taken physics. So I know a lot of the calculations and the equations and the factors that go into figuring out the distance, the muzzle velocity, the angles, all the stuff that go into the project before you start working with your hands and building it.
Wow. So how does this app development relate to what you think you may want to do when you go off to college or as a future career in folding in some of that physics experience?
Okay, so what I'm mainly looking for in a college is a physics-heavy department, but I also recognize that if you're going into science, you're also going to want to know some engineering basics, because they're so closely together, science and engineering, that you're bound to overlap at some points.
Great, great. And Libby, it sounds like you had some experience with development prior to getting into this class. So I'm really curious, how did you get involved?
Last year I actually was in the MAVA program with K-12, and I was able to take a C++ coding course. I actually didn't want to take it. I wanted to take computer 3D modeling, but they didn't offer that for whatever complications. But it turns out that I actually really liked it. Although when I took the class, I was already familiar with a lot of the concepts, so it was kind of just spewing out projects and mostly just sitting there. But coding is a lot of fun, and I've always been really interested in it since like bulletin board coding at like 10 years old. So it's always kind of come like naturally to me that I'm able to like understand what's going on and how to write it and whatnot.
Sure. That's great. Great experience. Thank you.
You know, and early on, when we first started doing this, we sat down with the kids and we tried to explain, you know, what engineers do, what engineering's about. It gets kind of dry, you know. And, you know, when I was in high school, the only answer I got was, yeah, they drive trains, you know. But
We've come a long way then.
We've come a long way, and you know, these projects really help engage the kids. And for example, this process that we went through to develop this includes all the processes that an engineer would do. You know, you're given a set of requirements.
Sure.
You have a brainstorming session. Okay, how are we going to go about this? You pick out intake data. This air cannon was Libby's idea. Okay, but there's a number of ways to do it. You could have used a catapult, and we had another linear type device. So we put them all together, we took data, and then we sat down, and we had what they call a down select, and said, which is what do we think the best way to go is? And then from there, you know, like Ryan was involved in doing a lot of the calculations to support, you know, our assumptions. And right through to building it, and now we're going to set it up and we're going to try to use it.
Show it off.
And even after the contest is over, wherever we fell short, we're going to go back and we're going to pick up those pieces.
Make some tweaks.
So it's a great way to do it. And I think the kids are more engaged that way rather than them sitting there listening to somebody like myself blather on, you know, that's boring. So it's been fun.
It certainly sounds as though the process that you've outlined is something that you would find in a real-world employment setting, where you're talking first and planning first, and then executing and using data to make sort of tweaks and improvements throughout. So I think your point about making this a real-world environment for students, and maybe not using a lecture-based
and oh, by the way,
setting.
we have a schedule to meet, okay? And we're not getting there, you know, so on and so forth.
The demands of the job,
yeah,
as
right.
they
I mean,
say.
it's that's the way things are in the real world.
Great,
so.
great. Well, we're actually going to show the pieces that you've all put together to make what will be demonstrated at the program or the contest this evening. So Bob and I are going to join Jason and Brian to do that. So if we want to head over and you guys sit tight, sound good?
Yeah, sure.
Okay, so first let's start by introducing you. So we have Jason and Brian. Jason, if you want to just kick things off.
I'm a junior at Taconic High School, and Brian, you want to go?
Well, I'm a junior at Taconic High School. I'm in the Science and Engineering program. And basically what me and Jason have been doing is working and testing these items on the table.
Yeah, so we put them together, and like I said, we took data. We had to take data, so everybody was involved in that. So, and you know, these are the devices that we talked about.
These three here in front.
These three in front are the electronic devices.
This is our Arduino.
Yes.
This is what we started off with, like.
Arduino?
Yeah.
What does that mean?
It's just the name of like the company that makes them.
Got
It's
it.
a
Thank you.
processor board.
Yeah.
Okay.
Yes?
That has multifunction or multifunctionality.
Okay.
There's a number of things you can do with it. And the way we taught the kids about the Arduino was it's open source software that's they can get online.
Okay.
And there's a number of projects that they can start out with that are simple projects. Like, for example, turning an LED on or off.
Okay. Using a
your
smartphone.
cell phone. Yeah.
I see.
So it demonstrates the fact that the cell phone has Bluetooth capability, so you can put an app on your cell phone, and that Bluetooth talks to a Bluetooth device that in turn talks to the Arduino, and then does whatever function you may want. So we started out with simple ones and kind of built our way up. And you know, you get to a point where the board can control motors and servo mechanisms.
And that's where this comes
And
in.
that's where that comes in.
So this is.
So what is this exactly?
This is a cart. Well, like we had to build this, and then we put the Arduinos at the bottom, and then we put this motor shield on, and these batteries like turn on and off. So like we had to write the code to make it our first. We had to like make it go forward, and like the code that's on it right now, it makes it go forward and then backwards, and it was just basic C++ like coding that we had to put in here to make it work.
So it sounds like you used an app and then you went from being able to just go forward, just going back. So you built on the technology that you already knew progressively.
And it was, at first it was kind of difficult to get it to work, but like it gets easier as it goes on, because we just built, like you said, we just built on to what we already knew and just the basic stuff. Like we started off with LED lights and just built off of there and just went
you
to
start
this.
out simple and build your way up.
Build your way up.
You know.
The other things it looks like you have here, is it looks like you have what I would assume is a drone. a catapult, and then when I walked in this morning, I actually wondered, was this a microscope in some way? But that's not at all what this is. So Brian, tell me what this is.
Well, it's an air cannon that we made for the competition that we're having tonight.
Okay.
Basically, all that is just PVC, and this is the air reservoir. This is the switch to let the air out, and this is the barrel.
Okay.
This is actually a sprinkler valve that we.
This here.
Yeah. So we usually have a button, but at the competition we'll have it'll be Bluetooth controlled, so we can fire without like being here.
Okay.
And it's on a what they call Lazy Susan, I guess.
Yeah.
That's right, for our viewers at home who are used to seeing these on their dinner tables.
They did learn what a lazy
That's
Susan
right.
was.
That's right.
And how it basically works is we're gonna have a bike pump or a ball pump, and it's gonna be connected to here.
This piece
Yep.
here.
And we measure it by PSI, pounds per square inch. We used a pool gauge to like measure it, and we literally we pump it in, and we go about anywhere between like 30 to 25 or 20, and that usually gets the job done.
So they had to take data and they had to correlate,
Sure.
you know, the distance that the ball flies, given how many pounds of pressure we had in there, and so on and so forth.
And you can tell the pressure by this
Yeah, by the
gauge
gauge
here.
right there.
Yes.
Yeah.
We actually got that off a pool gauge. Yeah.
So we have a Lazy Susan.
Yep.
We have a sprinkler valve.
Yep.
This is off of a pool.
Right.
Yep.
And is this, did I understand this is a pump, a basketball pump or
That's,
something?
No.
that's out of a truck tire.
A
Yeah.
truck tire
Well,
with PVC piping.
yeah, we pump the air with a bike pump.
Bicycle pump.
Yeah.
Great. So, and this is intended to make the ball go
30 to 50 feet.
30 to 50 feet. And is that what you were judged
that
on
was,
this evening?
that was one of the requirements, was that you have to have that kind of range. You have to be able to change the azimuth so you can point at different targets. What they're going to do is they're going to lay 4-foot targets on the floor. Okay, and you got to lob the ball onto the target.
I see.
Yeah.
So you've tested this already?
Yeah,
Yes.
almost killed people, but
Oh, good. Nobody was hurt today, folks. That's for sure. So you're demoing this tonight. You're going to show
Tonight.
this off tonight.
Yeah.
And what happens when you win?
you basically get grant money.
You get grant money.
Yes.
That's exciting.
Which this was bought with, and this
This will be used to basically inspect the Housatonic River with a boat that people at BCC have been developing.
Really?
from
Yes.
last year's competition.
Yeah, just as an aside, you know, over the last couple of years, we've got over $1.5 million that we've used to upgrade all our technology equipment for the STEM program.
Right.
Okay, and you know, we're very well equipped. Some kids have come back from RPI and said, "You guys have better equipment than we do."
And it's right here in the Berkshires.
So we have good equipment. You know, I'm talking about up-to-date equipment like 3D printers.
Right.
We have CNC machines, and so on and so forth, as well as all this technology. So the program's well funded, and
Right.
it's.
For those that are just tuning in, this is Access Higher Ed, and we're joined by students from the Taconic High School program, as well as their adjunct instructor, showcasing the relationship between Berkshire Community College and Taconic to use technology and engineering between the two schools and sort of get students on a pathway. So they're showcasing right now what will be featured tonight at a competition sponsored by General Dynamics. And then I also wanted to talk very briefly about this. It looks like a catapult.
It is.
Yes, it is.
Yeah.
Basically, this was our first idea, and we found out that it doesn't have the range, and it's not consistent enough for our use.
Yeah, it's a
So-
little harder to use
Yeah.
than that. So.
In terms of the requirements, you had mentioned that you needed something that you could move about,
Right,
and it
right.
looks as though this one would have been sort of limiting in doing
Well,
that.
well, probably what would have happened had we decided to use that would have been mounted on
I see.
the Lazy Susan, and we would have
I see. So are you looking forward to this competition?
Yes.
Yeah,
I'm
do
looking
you-
forward to winning.
You think you're going to win?
Yeah.
Yeah? Well, we're rooting for you. How many teams are going to be there tonight?
Oh, boy. Last year, how many were there? There was, what, 17? Yeah.
Okay.
Yeah, there's schools all across the county. And some schools have more than one team. Some schools have 3 or 4 teams.
I see.
Yeah.
I see. I want to ask a follow-up question about the drone. So you mentioned that this is something that was developed for a boat.
Basically, it's going to be used. It's not going to be a boat. It's going to be used with,
With a boat.
like, yeah.
Okay.
Yeah, last year, the project last year, or the competition last year, the requirements were different, okay, for General Dynamics. And last year, we had to build a boat. And the boat had to be run from your cell phone, again, controlled. And you had to be able to steer it. And it had to be able to pick up what they call trash. They threw balls in the water, and you had to bring them back to the port. Okay, that was the contest last year. So we actually ended up building the boat, and it's going to be used in some research projects that the environmental people are doing with local ponds. Okay, so we're using the boat to go out and take pictures and take samples and things of that nature.
Great. I also wanted to acknowledge, he's not on camera with us today, but John Tatro is a much-loved faculty member at Berkshire Community College and is clearly loved by the students at Taconic. And so he's here, you just can't see him, and works very closely with Bob, Brian, Jason, Libby, and Ryan. I just wanted to ask quickly, Brian and Jason, why do you stay involved with this kind of program? What attracts you to working, with this kind of technology? You don't have to go to a contest tonight, right? It sounds like something you're excited to do.
Yeah, we just like the hands-on and the research that was involved with this. I think that's very helpful for us to kind of just get a look at what engineers do.
Sure. How did you get attracted to joining this class?
Well, I kind of wanted to be an engineer. I just wanted to see what it's like before I went to college for it, so
Sure.
thought I'd try this academy out.
Engineering's kind of in your blood. It really is.
Yeah.
Engineering's the type of person that's drawn to that, just naturally has that, they call it the knack, if you will,
Sure.
You like to play with things, take things apart, know how things work, so on and so forth.
Yeah. Jason, how about you? How did you get involved?
So we're involved in the Science and Engineering Academy, and I was asked to join because I was really interested in the engineering part, because what I'm thinking about doing is some type of engineering, most likely computer engineering and stuff like that. So at first, what we did at first was writing code and learning C++ and stuff. That really got me attracted, and then just learning about the competition and doing hands-on and actually learning instead of just sitting there hearing them talk and teach, we actually hands-on and stuff. So that just got me really interested in this, and yeah.
Did you think when you started participating in this class that you were going to go into a lecture hall and just sort of be talked to, as opposed to having a more hands-on experience?
I thought that was going to be what was going to happen, but I was pleasantly surprised to see what class is actually like.
Yeah, this seems far more exciting than just
Yes.
sitting and looking through books and learning from a professor, although I know that Bob and John have lots of knowledge to share.
Yes,
but
they do.
the infusion of these kinds of activities seems like it's a more rich and maybe more exciting, more fun experience.
Yeah. Yeah.
So you plan on continuing down this pathway as seniors?
Definitely.
Yeah.
Yeah?
Yeah.
Great. Well, thank you both. We really appreciate
You're welcome.
your perspective. And want to just share a few more words with Libby and Ryan. So you saw, our viewers got to see a little bit about what's going on tonight. Just wanted to get your perspective. If there's anything else that you want to share in terms of your involvement with this afternoon's or this evening's activities?
We can talk about other programs that we have done that we didn't bring with us. When we were first starting, one of the first programs that we did with the Bluetooth connection was we had a little LED platform sort of thing, and we're able to light up the LEDs remotely with the phone. And even though that seems like really small, it was hard to figure out originally. But it was very fun to do because the professor purposely didn't give us too much information so that we'd be able to find out ourselves. And that was a lot of fun, just being able to start with very little information and be able to figure out the rest, which is, like he mentioned, how engineers work. They're able to overcome such obstacles.
Sure.
And also, shortly ago, to learn the basics of the MIT App Inventor we talked about earlier, we went and made little mobile games, each separately. I made a sort of Space Invaders sort of game. Libby, what did you make?
I made a generator so that you could generate your own mythological monsters, and it had like a little picture of all the animals that it would be composed of.
That's great. That's great. Well, I want to thank you for joining us, Ryan, Libby, Bob, our friends Jason and Brian, for sharing what will be demonstrated this evening. I feel like we got a sneak peek into what's happening, and we'll be looking for your results and how you do. I expect that you will win. I'm sure you will. No pressure, but can't wait to hear all about it, and and look forward to maybe having you back on the show at some other point to tell us about future projects that you have. So
I want to thank John
Tatro. Yes, thank you so much.
He's got me involved in this, and I really enjoy it.
That's true. We would be remiss. So thank you, John. Thank you to our guests, and also thank you to Pittsfield Community Television and Miss Hall's School for being a great crew. See you next time.